some concept of a decision tree, and in this decision tree, we understanding of two things. That is a entropy, entropy, and the second one is a Gini impurity. Okay, Gini Gini impurity. What is the entropy and Gini impurity? Basically, these both are useful for a checking purity of state, purity of state, right? This is used for checking the purity of a state. Similarly, we understanding one by one concepts. So first we are going with the entropy. When we talking about the formula, so is a just by just is equal to minus p log of 2 p positive minus p negative log base of t, and that is a formula that used for calculating the entropy, right? In entropy, what is the p? So one by one understanding the concept what is a p, and similarly the for Gini impurity the formula is a gi is nothing but 1 minus summation of I to 1 to n and p square. Summation of p square. What is the p square? That's all concept you will understand in that particular video. So what is the p? P basically is the probability of yes and no, right? Okay, probability of probability of yes, and similarly, this is the probability of no. When we think about the binary classification, okay, when we think about the binary, in that binary case, there is probability of p. It means the probability of yes, and this is the probability of no. And what is the p? We'll understand the concept with when you when you go forward. Okay, so that's the formula for entropy and entropy. After that, we simply select the feature one, and we split that in both sides. That is the one is the class one and class two. In class one we have 3 years and 3 no, and similarly in a class two we have 3 years and 0 no, right? That's we have a class. And how do we calculate that splits are pure or not? Okay, so that concept you will understand. First of all, that's we have a formula, and we input the data. The h of s is nothing but minus p plus log of base 2 p plus minus p minus log of base 2 and p minus. Okay, so in that particular case you will see the minus, and what is the probability of p positive for a class 1, right? Probability of in class C, probability of p is a 3 by 6, which means when you calculate the 3 years and total number is a 6, it means probability of p is the 3 by 6, right? Log of 2, and similarly 3 by 6 when negative, when you similarly calculate the probability of no, right? When calculate the probability of no, so is this same also because no also 3, so 3 by 6 log base of 2, 3 by 6. That's the for for a class 1. Okay, and if we calculate that, so when we calculate then this all are collect using the log of all the things, so we get a one. One it is the impure speed. Impure speed. There are no boundaries, right? And purity and impurity is always in between the 0 to 1. Okay, so purity and impurity always between 0 to 1, right? 0 to 1. So we if we get a 1, it means it's a pure it's mean a impure state, right? Similarly, calculating for a S of C2. So in that particular case, we have simply no, probability of, okay. So that you will see in that case we have a simple data that we are calculating probability of, what is the probability of 3, positive probability of yes, yes basically minus 3 by 3 log of these two, and 3 by 3 minus what is the probability of no, probability of no basically 0, 0 by 3 log base 2 0 by 3. So this become a 0, right? And we get a minus 3 by 3 log base, or basically we simplify them. This is basically minus 1 log of 2 1. So that's we get a 0. This is a pure split, right? This is a pure split. I hope you understand. So what is split? That's the, this is a probability of yes, right? And similarly, what is the minus p to the base minus is the probability of no. That's concept. And when the one is came, it means it's a impure split. When zero are came, then it's a pure split, right? And similarly, when understanding the concept of the Gini index, okay. So in the Gini index, that's we have a formula. That we have a formula is the minus one summation of p square. What is the p? P x means probability of positive and negative both sides, right? So we basically sum of both these things. So in that case, we get the same example, and we calculate the Gini index. Gini index is nothing but one minus summation. It's mean when we calculating for a Gini index for a class one, right? Gini index for a class one. So in that particular case, when we calculate the probability of summation of, so is a whole square plus, that's the whole square, okay. Probability of yes and probability of no, that should be to both of whole square. And 1 minus what is the probability of p. So in that case is yes and no, right? The probability of yes basically 3, 3 by 6, 3 by 6, this means we can write simply 3 by 2 as well, and we simply get a square of that, plus probability of no is the same 1 by 2. It's still 3 by 2. So 3 by 6, we simply calculate the 3 by 2, right? And that's we get. And we calculate all of these concepts, we get a 0.5, right? This is a for a Gini index. So in that conclusion, you will understand when you calculate for a Gini index, basically Gini index impure split are a 0.5. It's a maximum, right? Maximum. And similarly, when you calculate for a calculate using the entropy, in a impure split, the maximum is a 1, right? That is a concept of a Gini index and Gini impurity. Uh, okay, so this is the concept that we're using in a decision trees. Similarly, one more thing we are understanding in that particular thing, when we draw a graph, okay. So when we draw a graph that is zero with respect to yes and no, okay, with a h of yes, okay. So that's a one, that's the that's 0.5 u, that's the one, and that's the 0.5 u. That when we use a graph, so for a entropy is a maximum is a one, right? Maximum is a one. So when you create a graph. The graph is look like something that, right? That's this graph for a entropy. This graph basically for a entropy, right? And similarly, what is the maximum amount of impurity for that Gini index? Gini index is 0.0, sorry, 0.5. So that is the someone here, and graph is creating something like that. So this is for a Gini impurity.